Welcome back. In this video we're going to look in much more detail at the process of hypothesis testing that we introduced in the last video. We're going to work through all three objectives in this section. We're going to talk about determining the null and alternative hypotheses. We'll talk about type 1 and type 2 errors. And we'll begin talking about stating the conclusion to a hypothesis test. Now, we have a definition. A hypothesis is a statement regarding a characteristic of one or more populations. Now, the key word here is populations. One thing to remember when we're looking at our hypotheses is that they always deal with characteristics of populations. That's a key idea. And in this chapter, we're going to be looking at hypotheses that deal with a single population parameter. So let's look at a few examples. A Reader's Digest poll in 2008 found that 62% of American adults regularly volunteer their time for charity work. But now, a researcher believes that this percentage is different today. So the question here is about the true percentage of the entire population of American adults who volunteer their time for charity work. That's a population parameter. That is, it's the true value of a characteristic of a population. And so the question is about whether this percentage is different than 62%. Here's another example. According to a study published in March 2006, the mean length of a phone call on a cell phone was 3¼ minutes. And now, a researcher believes that the mean length of a call has increased since then. Now, the parameter in our last example was a percentage. Remember, it was the percentage of American adults who volunteer their time for charity work. But here, the parameter is not a percentage, it's a mean. We're interested in the mean length of calls made on cell phones and whether that mean is greater than 3¼ minutes. Now again, the idea is that we're interested in the true mean, that is the mean across the entire population of cell phone calls. And so again, that's a population parameter. And here's one more example. Using an old manufacturing process, the standard deviation of the amount of wine dispensed into a bottle was 0.23 ounces. Now, this manufacturer has new equipment, and so the quality control manager in charge of this manufacturing process believes that the standard deviation has decreased. Now, in our previous two examples, the parameters we were interested in were a percentage and a mean. Here the parameter is a standard deviation. It's the true standard deviation of the amount of wine dispensed into bottles across all the bottles of wine produced by this new equipment. And the question is whether this standard deviation is less than 0.23 ounces, which is what the standard deviation is believed to have been using the old equipment. Now, there's a key idea involved in each of these examples, and that's that we're interested in the true value for some population parameter, but that true value is unknown. Now, it's usually impractical or even impossible to access an entire population. So that true population parameter is going to remain unknown. But what we can usually do is to take a sample from that population. And then our hypothesis test is going to use the sample data in order to reach some conclusion about the population parameter we're interested in. And so another key idea here is that if the entire population data were available, then there would be no need for inferential statistics. So, hypothesis testing is a procedure where we'll use our sample evidence to test statements about some characteristic of one or more populations. Now, there are three main steps in hypothesis testing. And by the way, we're actually going to split this up even further into 6 very specific steps later on. But for now, think of it as 3 main steps. First, we make a statement about the nature of the population. Next, we're going to collect evidence, and our evidence is our sample data, and we use this evidence to test the statement about the population. And finally, we're going to analyze the sample data in order to assess the plausibility of the statement about the population. So again, we're going to eventually split this up into 6 very specific steps, but broadly speaking, we can think of hypothesis testing as these 3 basic steps. We make a statement about the population, we collect data from the population, and then we analyze the data to assess the plausibility of the statement. Now, let's get a little more specific. We begin with the null hypothesis. We'll denote the null hypothesis by the symbol H sub 0, or sometimes this is read as HO or H naught. The null hypothesis is what we assume to be true until the evidence indicates otherwise. So depending on the problem, we'll often say that the null hypothesis is a statement of no change, no effect, or no difference. Now in this chapter of the text, the null hypothesis will be a statement about the value of a single population parameter. And then the alternative hypothesis will denote as H sub 1. Sometimes you'll see this written as H sub A. And this is the statement that we're trying to find evidence to support. And again, in this chapter, it will be a statement about the value of a population parameter. So now, in this chapter, there are going to be 3 ways that we'll set up the null and alternative hypotheses. First of all, the null hypothesis will always be, at least in this chapter, that the population parameter is equal to some value. And then the first way to set up the alternative hypothesis is to say that the parameter we're interested in is not equal to that value. And so for reasons which will become clearer later on, we're going to call this a two-tailed test. Then the second way to set up the alternative hypothesis is to say that the parameter we're interested in is less than the value given in the null hypothesis. This is called a left-tailed test. Now, one way to remember this is that the inequality sign in the alternative hypothesis is pointing to the left. Now, as we'll see later on, there's really a more substantial reason why we would call this a left-tailed test. But for now, just remember that it's the same direction that the inequality is pointing in the alternative hypothesis. And so the third way to set up the alternative hypothesis is to say that the parameter we're interested in is greater than the value given in the null hypothesis. And so we'll call this a right-tailed test. So, to sum up, the null hypothesis is a statement of status quo, or no change, no effect, or no difference. And it's always going to contain an equal sign. And a really important and key idea is that in a hypothesis test, we begin by assuming the null hypothesis is true. It may not be, but the test runs based on the assumption that it's true. And then the claim that we're trying to gather evidence for determines how we write the alternative hypothesis.